Okay, we're live a little earlier today. Nothing going on here. Let's take a look at some experiments, and then we're gonna do some stuff on GPU drive. I think I'm just gonna make a GPU binding for Puffer. It's like the Puffer should have a GPU env binding anyways, so we're just gonna make that possible. That'll be way easier. We'll get some results. It'll be fun. Interesting. So this trained for longer, it looks like, than before. Oh yeah, that actually did the full run. It was just faster than expected. So that's a 20 bill run. You can actually see that after a while it's oscillating is a little weird that the environments are synced up like this. I thought I'd broken this up, but levels go up. Norm reward is low. But let's see, level means are good. Reward goes up and stays up. It's a little oscillatory, but it's good. I don't know if we have the smoothing enhancements on this yet. We should look at that. I think we probably don't, is why this isn't so nice. Reward distance. Okay, this is a little sketchy that it goes up and then back down. Reward tower. Yeah, this is sketchy here for sure. This should be straight up. So my guess is that it was actually doing well until right here. So it did very well for like 2 billion steps and then it crashed is my guess. I'm seeing all this skill usage here. Oh wait, this is just the burst movement though. Interesting. Well, we'd have to see what they actually ended up doing. Do we have entropy crash? No, interestingly, entropy goes back up. Value loss is insane. Definitely value. So value loss blew up. You can see right here. We'll have to do something about that. That looks like hyperparam screw up or something. Which makes sense. We have a really, really dumb setting right now for value function clipping and stuff. Which, I don't know, the hyperparam thing. We need ELO as an optimization metric. But hey, we can run, we can do full runs now. We've fixed that environment bug. This is pretty good. And was there anything else? I think we had like one other thing to look at, right, before GPU drive. Maybe this. Yeah, Sequest. All right, and we have reasonable train curves for Sequest as well. These look quite nice. So we've got pretty much good hyperparam sweeps on everything. I am a little bit curious as to why, with so many of these, it doesn't choose to do longer runs. You know, it has the option to do longer runs, but it doesn't do it. Well, no big deal. In any event, let's get on GPU drive. So let me reply to one stupid thing. let's do a couple things. So, first of all, we're going to fix the stuff I broke yesterday. Not going to do this. Going to break some stuff. Now what we're going to do is we're going to go look at the environments. Where is it? I think what we're going to have to do is we're going to just have to accept that this is going to be a GPU environment and we're going to make a GPU binding. And if we can come up with a way to do CPU binding later, we'll do it. I think Madrona needs to be compiled with CUDA. Is that a thing? Let me check. Let's test that first. This is frozen. If I just set this environment to be CUDA, what happens? Madrona was not compiled with CUDA support. Okay. Okay, so this is the one thing that I do potentially need. Is this here. This goes in the torch env. And everything else I don't really need. So we'll do stash. Untracked external Madrona. How do we compile Madrona with GPU support? Let's see. I don't see anything on Madrona compile here except maybe this. External Madrona. This is just their sample. CUDA, I have this. Dependencies are needed. I think WSL should work, right? It's possible this just doesn't work in WSL. Let's like commit some stuff up on Puffer and let's get this set up on the bigger Puffer box. Because I don't want to be fighting compilation errors and stuff if it's just going to be because of my local setup. So, which box do I use for this? I think actually, is it Puffer box 1? Let's use Puffer box 1. Make sure this is clear. Yep, we're good. This was just being used for Atari. Everything is synced. Let's grab GPU drive. Should I fork it, actually? Let me fork it while I just have the... Yeah, let's fork this into Puffer. In case I need to do this. That'll make it easier if we need to PR anything, right? This has to be recursive, doesn't it? Well, my bad. Whoops. Good news is, this is actually way faster because this is running on the Puffer box, which is connected to better internet than I have here locally. And we'll do this manual install, and then while this is running, we'll handle some other stuff. And this should compile with proper GPU support. We'll run some tests. We'll run some tests. This will also be the first time we'll be adding a GPU environment binding to Puffer, which, like, really Puffer is not going to be able to do very much, other than, like, do some hygiene and maybe, like, some decent integrations. So you're not really getting the full benefit of the Puffer stack with this, but hey, you know, it's a cool environment, so we have at least some tools that they'll find useful, I'm sure. Cool. So on dev branch, set up vector and clean PufferL. We also need to add, where is it? Environments GPU drive. All right, environment, torch, and ini. Yeah, let's do this as well. Okay, so that's actually perfect timing for us. Now we have this compiled. And pip install -e dot. Yes. Oh, it just cd'd us into build. We're good. Nice. So now we have this installed. pull this down. We would also like to have this test GPU drive file. We probably don't need that, though. We won't need it. So the main thing that we're going to have to figure out is we're going to have to figure out how we want to pass CUDA tensors around. I don't think that's terribly difficult. We're just going to have to add a couple things to clean PufferLib, I think, which is like, it's fine. I try not to blow up that file, but I think like adding it's like a couple if statements. It's really not a lot. Whoops. I hate when I actually accidentally get into tree mode. Okay, so this gets changed to CUDA. Right, and we don't need .numpy now. So this can be .view. Let's give it the full ob space. Live agent mask is... We're not using this yet. It's going to end up having to be a torch tensor. We don't need this to be like this. We just need action equals action.view like this. Step dynamics. Don't need any of this. It's just going to be reward. View num worlds. Zeros like dot two terminal dot device. We'll do that. And this will be slow, so let's make fast. And I think that's literally it. Yeah, this isn't supposed to be hard. So now that we have this environment, I'm trying to think how I want to add this. I think all I have to do because technically this is going to get wrapped in a serial at the moment. And that'll screw it up, right? What I want is I want to just use this directly. I think what I should do is I should just make... I should make a new vec backend that is native. And the native backend will just take whatever data you have and pass it through. Let's see how I will do that. So what we'll do... It has to have the same signature like this. Okay. And then env. Hurry up. Get it done. Well, have you ever had shit break because of multiprocessing start method for 5 hours and unable to have CPU mode execution not take up all your cores and a million other cursed things? Fucking Madrona gave me a hell of a day yesterday. All Madrona. So I'm adding a GPU binding to this, which is not going to be able to take advantage of all of Puffer's features, but at the least we're going to be able to get some fast training, and we'll be able to do some hyperparam sweeps and stuff. Because I'm not dealing with this unless Madrona has a fix for it, because their default multiprocessing is too slow. We had a problem at OpenAI this one time. Could have given me a call. I deal with infra hell all day, man. Four days of dev time. Yeah, I remember that they were using they were using for vectorization, they were just using like raw MPI, and it was just the worst garbage code I'd ever seen. It was bad. Um it was just like process conditional logic with no debugging whatsoever and no error messages. It was terrible. Yeah, that was rough. I, there is a better way, you know. You can just write multiprocessing. Jeez. GDB was like Greg is so freaking cool though. I remember he would just be coding with the Dota team all day. He had like a lazy boy type chair pulled up, and he'd just be there just like reclined and just like working on hard infra shit with the Dota team. It was awesome. I hope he's doing well. I have no idea what the heck is happening at OpenAI right now, but having no insider knowledge whatsoever, I'm guessing he's probably just actually taking a vacation because the guy's been working for 9 years, and probably like Schulman and a few of the other researchers have gotten sick of doing too much product side stuff because it's like hard to do science when stuff scales so much. That would be my guess, but I don't know. I don't think that they've secretly solved everything. I doubt it. Other thoughts on yeah, yeah. I spoke with Schulman a few times. I don't think we saw eye to eye on everything, just mostly because he is much more he's much more scientifically minded. I'm much more engineering minded. Though I started out when I was starting off, I was way more on the science side than I am now. Like I trended towards the engineering side just because like it was the thing that let me actually build stuff and get things done. And like I didn't see any way to push forward on the science when all of the tooling in RL was so broken that you were getting results on things that like could not be known to be useful. It was rough. I will say, I bunch of Schulman papers are like the actual ones that I keep referring to on stuff. I keep finding like really bad fuck ups in everybody else's papers, but so far it's been good on that. his single agent, he's on the single agent scaling paper, right? Yeah. So this paper here, man, this is such an important paper. I'm not going to my DMs live. Relax, I have 2 monitors anyways. But this paper is so important. That, like, because this paper basically confirms everything that I thought about RL, that it's like a data scaling thing, not a parameter scaling thing. I see. Thanks for the DM, Will. Yeah, that makes sense. Um, yeah, we'll talk about that elsewhere. But yeah, the fact that RL scales with data is good. I gotta start my stupid stream for web dev with Claude Slop. I need you to speed up your dev speed, sir. Look, it's you either write stuff slow and you get it done right, or you write slop, okay? You want a cool demo? Here. I think I can do breakout mode raylib. Does this work? Eval. Damn it, where is this thing? I think I have... Do I have the demo? Here. Okay, so I made a playtest where you can play... This is me playing. You can play it the way that the agent sees it. This is how the agent sees and plays Montezuma's Revenge. It's really hard because of frame skip and stuff. And then I made it... You can do this with any game. Any Atari game. And then you can set this to render mode human. And you can play the game the way that humans are supposed to play the thing. And you'll see that it's still ridiculously hard, but substantially easier. So, pretty much if anybody had bothered to do this, like, years ago, we wouldn't have been making stuff so hard with Montezuma's Revenge. This game is, like, ridiculously hard. I'm actually surprised I haven't died yet. Yeah, there you go. And it's, like, frickin' impossible with frame skip as well. It's like a precision platformer, legitimately. But you can get a few hundred points. And I think RL can get a few hundred points just fine. So there you go. Works with any of the games. Built that. That's a fun thing. I also did a run of 20 billion steps on the MOBA overnight, and I can tell you for sure that the hyperparams are bad. Argument is that frame skip is you don't need real reaction time. It's still an impairment because of how precise the game is. It's like a legit precision platformer. And oh yeah, sticky actions, forget it. Sticky actions totally screw stuff up. And actually, I found that it's even, like, people were, like, ragging on me for doing a clickbaiting with the title, like, all of RL is broken. No, it's even worse than I thought. I just said it was the default in ALE Pi, but actually, as of, like, V5.0, a lot of the V5.0 Gymnasium M's have sticky actions by default as well. So it's even worse. Frame skip is fine. Okay, frame skip is totally fine to speed stuff up, but here's the thing. You sweep it as a hyperparameter. You don't fix it. So you put it into your carb sweep or your whatever as a hyperparam, and then you go based on reward versus wall clock time, and then it's done, right? It's that easy. So that's what I've been doing with all these sweeps, is I have frame skip as a hyperparameter. It's not fixed. And that makes it really, really easy because I can just go down here and I can see, look, these are the runs that it's chosen 5 frame skip, 4 frame skip, 3 frame skip, and it doesn't have anything below that. And this is Sequest overnight. So this type of stuff is going to be really nice for RL. Frame skip is really a part of the agent code. People didn't want to change the env. Yeah, that's the thing is they didn't play the env. If they played the env, they would have. Yeah, well, this comes from me not caring about academia, right? If you're in the mindset of like, I don't want to have to convince reviewers that this is the right way to do it, you're going to make bad decisions, right? I no longer care. I'm not writing papers. I'm solving shit. So it actually, like, as soon as that like switch flips, everything started getting easier. Everything started getting easier. I think this NeurIPS paper cycle, the reviews will be back in 2 days for data sets and benchmarks. And then legitimately, I think this is going to be my last conference cycle. Like, unless I have something that's just super easy to write up, I probably just won't submit anything else. This is why OpenAI exceeded academia. Yeah, it was really good. It was really good. And the thing is, you do end up convincing people as well, because like you get this result, right? And it's like, hey, we can kind of just hyperparameter tune whatever, and like I don't need anything fancy, it just wins, right? And it's fast. You kind of like you have to exceed by a huge margin, but once you're getting these results that are just so good, like that's when people buy it. LM papers, LM papers. Did you train your foundation model from scratch? Yeah, ridiculous. This one was cool. You can see like it like actually latching on to finding like the good hyperparameter zone like this. All right. See ya. Thanks for dropping by, Will. Only Twitter. Are you only on Twitter? I'm on I'm on YouTube and Twitch right now as well. You're on all of them? Yeah, solid. Yeah, the YouTube audience is way better because of my thesis video mostly. I actually get decent viewership from there quite often. Um, has anyone done carbs for neural architecture? They kind of did in the original carbs. They at least swept the network sizes. So that's actually one of the things I'm going to do next is I'm going to add like some network size parameters into carbs. But you carbs is not purely magic, right? Like the more stuff that you add into it, the bigger the search space gets. It can't just like magically do gigantic hyperparam spaces. So I think once I like cut down some of these ones that are basically never need to be messed with, then I can add like a few scaling parameters in. That gets to be substantially more compute though. And I don't know. I am planning on building out the puffer cluster, hopefully relatively soon. That's going to have to be post revenue. But for now, I like the current cluster's got a bunch of issues. I have to RMA some boxes because of the stupid Intel CPU cluster fuck that's happened. In any case, you should make a neural arc. What do you mean a neural architecture search RL env? You can do it on any environment, right? You can just use any environment that's fast and then do neural architecture search on it, right? You're either about to say something that's genius or makes no sense. It's not doing RL on a game. Is this not what I said it was? Oh, you're not going to use carbs to train a generator network. That's not going to happen. That's too many parameters. I don't even know how much benefit you get out of architecture search these days. Like, okay, eventually, I say. Eh, maybe. We'll see how much benefit there is actually to architectures in general versus just compute and data scaling. I think like you might end up doing pretty well just by getting some basic building blocks right. We still don't even have a good way to do transformers in reinforcement learning. Like, not whatsoever. Not even close. They're just way too slow. Architect studying grokking has shown architectural limitations. Yeah, but you still have to be able to parameterize this space, right? Like most neural architecture search is pretty restricted. Mm-hmm. This is a very weird mechanic. Yeah, very weird mechanic. Whose paper is this? Hmm. Very high order bit to optimize. Look at this shit. What? You've got way too many papers. Oh, I saw this thing. Maybe I've just spent too much time in reinforcement learning, but like, my opinion of scientific papers in general these days is that they're wrong until proven right by test of time. Maybe I've just spent too much time in reinforcement learning. I don't know. How often is it that like LLM papers are just wrong? Because in RL it feels like you're just throwing darts. Like the majority of RL papers that are published at NeurIPS, even like spotlights and stuff, are just wrong. And they're like trivially provably wrong as well. That's a ban. Frickin' Twitch bots. Neural architecture search still has a place, and we can either do graduate student descent or do neural architecture search. And recent results suggest that architecture matter. Yeah, quite possibly. Quite possible. I think that this will get easier. Like, the problem is we need better. Like, Will, if we're gonna do this, we need way better compilation and stuff, because for RL, like the models are tiny and they need to launch fast. So like that, we're getting really limited by having shitty kernels for stuff. It's one of the reasons I write such simple architectures, is like you end up just getting screwed by like kernel launch times and stuff when the models are so small. So like you could do this, but it would almost have to just generate a monolithic fused kernel for the whole thing. Like even torch compile, like the freaking launch overhead's just brutal. So yeah. Okay. We go back to welcome YouTube folks. We're gonna add today we're adding a native vectorization method that's going to support actually it's going to support a few things. But the main use case is going to be GPU environments. The native vectorization is just going to say that your environment is already in the right format, so Puffer is basically just going to do a pass-through and allow you to use the GPU environment with the rest of our stuff. Okay. I think I can get rid of this. And get rid of this. And then I need to define async reset, send, receive, and close. Well, this isn't right. Nice job, Super Maven. Do you even set the flag like that in async? Yeah, you do. So all we will do is dot ready ems equals dot reset. So this is not actually async, but it doesn't return anything. It matches the function signature. What happened here? I don't know how I got into this serial code. That's weird. Okay, do this here. Async reset. So self dot ready equals self dot ems dot reset seed send. Yeah. And def receive. Okay. A few API things we have to do. Few API things. This thing is supposed to be able to return close. Yep. Okay, it needs to return everything. Yep, it needs to return everything. It's a little bit difficult, actually. Because I need to know the native data types, right? Oh, I know what it'll do. That's fine. We'll just assume that they return like that. We'll just make them... We'll just put the onus on the environment to do it. Yeah, that's way easier. And then in that case, this is literally done. This is all that this needs to be. And then all I have to do is edit the GPU drive environment a little bit. So we'll do vec is going to be choices native. Okay. You need to give it native like this. And then in GPU drive, we will allocate some buffers. So we'll just do dot reward dot zeros reward terminal truncated fine obs self dot reward terminal truncated. Okay, so this is going to be the vector API. And this is not a pufferenv now, right? Yeah, this is not a pufferenv. So to do not a pufferenv. There's some API shenanigans. Let's ignore API shenanigans now, because API shenanigans is stupid and boring. Obs reward terminal truncated info. Okay, this is good. This is good. And truncated can be self.truncated. Because it's never truncated. So let's get into this box. Let's see. We have to recompile CJE. No config for env name. Okay. I forgot to commit it. No big deal. Cool. Got our config. No module. Ooh. Huh. Is that not a thing we can do? I thought that this worked. Is there a symlink or something I forgot? I think that this has to be after the change dir, right? So can I just put this here? Assertion error. That's fine. Config. So what we're going to do is we're going to tell this to use one env, one worker. And all this is going to do basically is just like make the GPU env handle its own stuff. GPU. Do I need a symlink or something? No module, PyGPU drive. How do I get this working locally? I did make a symlink. Okay, that's fine. This is syntax. Yeah, that looks good. And then we know that error. GPU drive. Move. Build. GPU. Build. And for some reason, even though I'm on Python 11, this compiles as Python 10. You just rename it and it works. Image.io. Env torch env. Oh, that's obnoxious that you need image.io. No big deal though. Pygame, no module named Pygame. Yeah, those things should not be being imported like that. Madrona was not compiled with CUDA support. That's weird because it should be. I see nothing here that needs to be... I don't see anything that would prevent this from compiling with CUDA. We have this. We got Linux. GPU backend will be disabled. Oh, jeez. I actually remember this being a thing with Madrona. Is it not working with old CMake? I thought I put this into the Docker, actually. thought I had this in the Docker. So the thing that's going on here is like, this is one of the annoying curse things with RL, is like they're annoying dependencies, and this is what Puffer Tank is for. I suffer once, and then I put everything into the Docker, and nobody has to suffer again. I thought we had a CMake version here. I could have sworn we did. I think, wait, I might have a Discord DM. Hold on. I might have a Discord DM on this. Let me find this, because I remember fixing this exact issue before with Aaron, who was using it for a different project. And I could have sworn that he sent me the, Yep, I found it. Yeah, here it is. So, apt-get update. And then we're going to install a couple of things. Install wget lib dev. And then we wget. Don't do this here. Okay, so now we've got CMake, and then we do bootstrap. Cool. And then the hope is that this gets us a CMake that will actually work to compile Madrona with GPU build support, and then we'll be able to get this working. And then what I'll do is then I will just, like, once we have this project nice and working, in order to distribute it more easily for everybody, I'll just update the Puffer Tank base to have this nice new CMake on it, as well as some other hygiene stuff, PyTorch 2.4, not a dev build, stuff like that, and we'll go from there. Hey, Linky. As Linky says, if you haven't started the repository yet, and you find any of my work interesting or useful, start the Puffer. Not this one. PufferLib. All my work is free and available right here. So, this will take a quick second. I think that this was all that was needed, though, if I recall. Because I'm pretty sure we debugged this exact same problem before, and it was just straight up CMake. Hi, welcome. Get this man's free GitHub Copilot. I think, I'm trying to remember if I have that. I have, I've been using Super Maven these days. It's been way nicer. That looks like almost done. Maybe not. Anyways, though, this will finish. We'll compile, what am I doing today? Yeah, I probably should have started this stream with that, shouldn't I have? So there's this GPU drive simulator that was released yesterday. I was hoping to have day 1 support, but it took me a little longer than expected. It's an ultra high performance GPU accelerated driving simulator, and we're adding it to Puffer at the moment. Now, yesterday I wasted a lot of time. I was trying to get it to work in CPU mode because Puffer has optimization such that that can actually be faster. But we ran into just a lot of low-level bullshit and ended up just having a really rough day of it yesterday. So today, instead, we're going to just make a GPU binding. This will be Puffer's first GPU-bound environment. We're going to make a little API for it, and then we're going to ship it. And hopefully by the end of today, we'll actually have, like, experiments running on this thing and automatically tuning itself to get better and better at driving, which will be fun. But in order to do that, we must compile CMake. People have been asking me to do this for a while anyways. Practically speaking, this will be very simple to do. Okay. I think we got CMake. There we go. That's correct CMake version. I think you need to like close an open shell or whatever. Now what we're doing here now is we're going to do a manual install. Recompile. Yep, that's a recompilation. And hopefully this actually compiles the GPU support. Okay. Now we see whether this actually worked the way we expected it to. Really? Madrona was not compiled with CUDA support. How's that possible? We literally just compiled. No make clean. Why is this not compiled with GPU support? Do I have to go into Madrona and compile it there? Use C++, they said. It will be fun, they said. And just do this here. Oh, I think, is this doing it? I hope I don't have to redo compilation. I should have, like, warnings about GPU, shouldn't I? Let me see. So, compiles with some warnings. Could not find doxgen, including X11 support. Okay. Madrona was not compiled with CUDA support. What the fuck? Madrona was not compiled. Does anybody not get this? I'm trying to think what the hell else I had to do to get CUDA support working. I'm trying to think if this is likely to be... Oh, interesting. That's weird. Nice. CMake is actually picking up the... Oh, okay, wait. Maybe it's this? Set the Python environment variable. Python version for CMake. Is it dpython executable? on. Okay, so can I do this is the exact error that I have. CMake. Oh, can I just do here? Find package. I'm trying to figure out what I do for this. Compiler. I don't know how you get it to use a specific version of Python. Really obnoxious. Dang it, where do I... I think I have to do it like this, right? So we'll do CMake. dpython executable. Slash... It's not user local. Where's my freaking Python user bin? That ought to be good, right? Ignoring CMake. Okay, we're going to build. Does this do it? dpython libraries. Is it executable or libraries? I genuinely don't know. Oh, wait, I have an idea as to what might be happening, though. Yep. Okay. So what's happening is I think here. Copy GPU drive. I think I was rebuilding it, but it was to the wrong location. env is going to be drive mode train. Still no? Well, this is not even the issue then. I was sure that would do it. Do I have to like make from scratch maybe? Yeah. Let me just make sure because I think it's probably caching some stuff. Let's just reclone it. Oh, okay. This is interesting, right? Could not include cd build. Could not find the requested file. Because I'm stupid. Forgot you have to clone recursive. Okay. What is all this for? This is a high performance GPU driving sim. I'm trying to add support for add it to Puffer so we can train some cool models. Okay, so that does compile. Oh, wait, no, I just cloned it. What am I talking about? One step ahead. Yeah, see if it compiles. Okay, something happens. The thing that's not working at the moment is Madrona, which is the underlying engine that this uses, is for some reason is not compiling with GPU support. We have all this. What the hell? It's still not compiled with CUDA support. That's insane. I honestly don't know then. I guess I'm gonna get it working with CPU mode then first, and then figure that out later in the day, because I don't know otherwise what the heck. I can't get this thing compiling with GPU support. It's like really, really obnoxious. So device, we'll do device equals CPU. Then okay, that error we do know how to fix. My GPU and torch. So there's this one hot right here. No, it's on the road objects, isn't it? Yeah, I think right here. And we have, where did I put it? Here. Okay. Okay. This was what we wanted. Very good. Now, env ID mask. Right. So we have to add a couple things to PufferLib vec ID. I mean, we can add it to this for now. Self.env. Oops, not this one. Right here. So let's just do self.envid. Env config. No. Okay, so now we have self-envid. Obs rewards dones. Term truncated infos. Self.envid. Mask. And we'll do a self.mask. And what was the data type of self-mask? Is this an array or a list? I think it's probably a NumPy array. Forget exactly. Mask. Let's do that. And then we'll just return. Invalid tensor shape. That's fine. We messed with the model. We will unmess with the model now. Let's unmess with the model. We don't need this stupid thing. Still invalid input tensor shape? Okay. Where? Interesting. Before we even get there, right here. Just forgot to change a couple things back. We're good. Probability tensor. Inf, nan, or element less than 0. Oof. Okay. I thought we'd masked this. I thought we had masked this. I'm gonna go use the restroom, fix the AC. Be back in a minute. We'll keep going. Okay. We got a lot of stuff we can work on with this today. I think that the smartest thing is going to just be to get the end-to-end working, and then we'll figure out the GPU bullshit. So, Forge.max. Okay, it does have nans in it. It does have nans in it. Which is very weird. Oops. Let's look for the mask that we made, and we're gonna actually, what we're gonna do is we're gonna just make this mask way earlier. So what we're gonna do, nan to num. Yeah, this is, what I'm gonna do is I'm gonna take, We'll just do states. Yeah, we're just going to do on all of these so we don't have to deal with it. Wait, torch.tensor. That's funny how that works. Okay, let's see if this does it. Well, why the heck is there a giant observation in there? That's weird. That's going to crash everything. Okay, so where then should not be nans in the obs. I guess we just put a breakpoint and just see where we're getting nans. Nan. Okay. So how about this? Gigantic. Why would these be gigantic? Are some of them just uninitialized? Can I do like... Is this valid? Yeah. There is not... The normalization on this still... Oh, well, we're going to normalize after, right? So if I just do like this... Torch.max, ego... Yeah, perfect. Okay, so this works. Let's do partner observations. Roadmap observations. Max obs. Perfect. -1 to negative 0.5 to 1. Now we actually have some clean data. Hopefully we can do something with this. Where GPU drive environment. Index 16 is out of bounds. Well, that's not good. Let's see. Get rewards.view. This is wrong. Right? I don't even know how it did this. Type must be a subtype. Of ND array type. Okay, this is going to be a NumPy array, right? Yeah, so it is actually torched from NumPy. Perfect. We got it training. Very cool. And there are 2 worlds. Can this be made faster? Appears to be a little slower. Okay. Let me send a couple messages. Let me see how my DMs, if I have any DMs on this. Size. Some reason. Cool. Let me go make that GitHub issue. We'll see if anybody gets back on this. In the meantime, let us check. We had a doc somewhere. Okay, so algorithms SB3 callback is where they do logging, evidently. It's interesting that they use a deck. I see why you would do that. That's kind of funny, though. So they do global step. Mean reward. I see. So there's a .info dict. I see. A lot of code. Create and log videos. I generally don't log videos to WANDB, just because they take a ton of memory and they're kind of slow to generate. Though they are nice. Okay, so let's grab these and let's start making some metrics, unless I have an instance. Nope, no replies yet. So let's start on this. It won't be too bad. What I usually do with this is I define like a report interval. Let's say I make it 32 steps, right? And then I'll do I don't know if I want to log these every step. How do I do this in MOBA? So when I do like infos, right, don't I have something for this? Oh, where's my logging? I know I have logging somewhere. Levels, yeah. So I don't accumulate, so that's fine. Self.report interval. And then what we do in step is if we need to add a tick as well. Tick equals 0. Do this on reset. Self.tick plus equals 1. And this is wrong. It's going to be if self.tick %report interval is equal to 0. We do info equals self.env.getInfo. And info num agent num, was it finished agents. Oh wait, is that it? Actually, I might just be done. We'll just see what's in here. If I'm just gonna get the dict directly. GPU has no get info. Is it .info dict? No attribute. Okay. Does this have info dict? Is info tensor? Info dict. I can just look for it. Oh, update info dict. Is this? Is it info tensor maybe? Is that what it has to be? Well, that's not what we want. Oh, I think that this info dict is like manually. Do they just make this? Env info dim. Okay, so there's a bunch of stuff in this wrapper. A bunch of stuff in this wrapper. Okay, I can see right here. They actually have off-road vehicle collision school. Okay, so they actually just make this on reset. Controlled agent info. Info of indices. Wait, self.env.getInfos. Is there a getInfos? Was there an underscore? Okay, there is a getInfos. Except it's a tensor, right? Info tensor equals self.env.getInfos. And then And they do this on, okay, I see that they do it this way, which is probably what we want to do. They do it on episode. So we have to basically do what they did in this wrapper. This code is good. This is like a rare case where they actually did a really, like, they did actually wrote really good stuff here. And there's actually not much for me to do other than just write a binding. Unless we get CPU mode working. Then it would be substantially easier. Oof. Lots of cool stuff. Okay. I think we just do this in step, right? Instead of report interval. Yeah, we literally just do end of episode reporting, which is going to make it a little tricky when we do, if we do CPU port. But it's okay for now. So let's take this mask. Done worlds will be self dot controlled agent mask. This line. Okay. If done worlds any items there's a dead agent mask thing, but then there's also the info update, right? It has to reset. Which is slightly different. So EX self dot reset world IDX is equal to IDX. And then we have to update the info tensor with done worlds. Yeah, okay. Indices. Select info for controlled agents. So what we'll do is done worlds info road equals info tensor dot sum dot item info vehicle. Let me scroll this so you can see it. Collision. Oops. Info tensor sum dot item. Non vehicle collisions info goal achieved, and then info num finished agents self dot controlled agent mask. Self. Okay. And then we have mean reward per episode. Tote reward. How do we get tote reward per episode? I see, they actually have to do episode returns. Be set on reset, in fact. And on step, we do self.episode turns plus equal to reward. Total reward. Okay. Mean reward per episode. I think I have it. Let's see how this looks. Torch.where. Okay, let's see what's wrong with this. I see. So you have to do this before the reshape, I guess. So let's do like this. Slightly annoying. I think we're gonna store the rewards, the returns like this. And then the way that we're gonna get around this is we're gonna do, hey Noah, we had some trouble with this environment yesterday. This is day 2. I'm really gonna try to get the binding for this done. Then hopefully we'll be back to the rest of this stuff. How's breakout going? I don't know if you saw this yesterday. This is the GPU driving sim. Okay, we did get to our breakpoint. But this one's not particularly useful. Vec is done. Agent is not learning anymore. It's just going. Do the rewards make sense? A very easy test is if you just play the game yourself and print out the rewards as you're playing it on every tick. See if they make sense. That'll catch 90% of stuff. Why does this not have items? Reward is just the current score. Well, that's a bad reward function. It should be 1. The reward should be like 1 every time you break a block. It should not be the current score. That's a really, really bad reward function. That's the problem. Why is that bad? Nope, because here's the thing. First of all, there's the scaling of the reward. Your reward now goes over many orders of magnitude, which is bad. Second of all, if you think about it, like now your reward is like if you're at score 100 and you get to 101, that's a very small difference in score from one time step to the next. And third of all, the value function also now has to learn to predict the score. So it has to learn to like read the scoreboard in order to be able to tell, unless you have a wrapper in there. Creates all sorts of difficulties for the algorithm. You definitely do not want that reward function. It's good to have like a nice continuous reward function, but the thing you have done is not actually a continuous reward function. You've not given it any additional information over giving it a 1 every time it gets a block, and you've poorly conditioned the reward in the process. Change it to 1, it'll work. You give the agent. Yeah, that shouldn't take you very long. You just set reward to 0, and then if it breaks a block, you set it like +1. Do that, retrain it. It probably just learns instantly. I mean, I literally have a sweep of the other breakout game, like the original breakout on Puffer, and it works. So yours should learn super fast. I'm hoping we can get this down to a like we can get it so that it's very nice and consistent and easy to implement a bunch of these, and maybe we can implement, like maybe we'll do like the original 7 Atari games. So we'll have like 7 fast Atari games for Puffer or something. That might be fun. Ultra fast. But the key is they've got to be like the full game, right? Like there's like Minatari or whatever from Jax. Like we got to do the full games. We don't want stripped down versions of the games, right? Yours is good. Like if I were to do Pong, for instance, I would actually have to do the Pong physics because there's actually like some kind of intricate acceleration in there, stuff like that. This looks fine. Maybe controlled agent mask is the wrong dimension. No. Let's see. Is it dot item instead of dot items? Yeah, I'm dumb. It's just dot item. Broke my terminal. Good job. Eh. Okay, so this seems to be working. How about this now? Env.reset world IDX. reset got unexpected keyword arg world idx. Okay. Env is GPU torch env. Self.reset. Maybe the self reset is not what I think it is. Here it is. It's self.env.sim.reset. Nope, where is it? Self.env.sim.reset world or just IDX. See this. All right, cool. Very nice. Do you need to get the info before you reset it, though? Wait. Wouldn't you need to... Yeah, you need to get the info before you reset it. Oh, which I do. Look at that. That's nice. So my info should be returning, shouldn't they? Why my info's not returning? Info's got stuff in it. Returns directly from step. Do we get here? No. Internal stop iteration. Internal stop iteration. What? Oh. It needs to be a list. Is this the env batch nonsense? Well, you have part of it right in that it is a lot of nonsense. You definitely have that correct. So I give you full marks for that. Good job. GPU drive. That's nice. The puffer difference. Do I have any messages? The question. All right. Let's go figure out. We have to figure out a few things from here. First of all, do we have a reply on GitHub? Oh, we didn't even check this one. No, they never replied. How about our GPU drive issue? Actually, I kind of want that tab. That one's annoying to find. Cool, and we got a good reply here. Okay, so from here, click a few things. So from here, we have a few options. I think we want to get the masks working next, which will unfortunately drive perf down a fair bit. But, you know, it'll come back once we get the GPU Excel. And then some. Give it some garbage. Do our housekeeping. Okay, so we have We can just do self.controlled agent mask, right? Let me see how they do their live agent mask on the GitHub. Where'd my tab go? Here we go. So I want to figure out how they're doing their masking. The idea here is that agents can die, the cars can crash, or they can achieve their goal. Either way, they'll be removed from play. And there is some masking that has to be done in order to accomplish that. So we, right here, dead agent mask. Let's see. They initialized it up here inside of reset. Okay, so we can do, that's fine. And then what they do is they use this as a mask everywhere. Cool. And then they logical OR right here. And yeah, this is what I was... Right here, this is, they need to reset it. Okay, so it's basically the code that I expected. Let's add this ourselves. So self-controlled agent mask is here. And then in reset, we'll do live agent mask, self.controlled agent mask dot clone. And do they use for logging, do they use the live ones or what do they use? They use the controlled mask for some reason. So we'll keep that there. And then on step, they update it somewhere. They update it after logging. So they'll do self.mask. Agent mask dot clone. Okay, so we get the mask from there. And then now down here in step, we do mask. They do it before resetting. Yeah, they do this. I think I can technically do this up here, though. If I just do it up here. So I just set the mask of terminal to be false. So you can no longer see the dead agents. And then here in reset, we have to do Well, that's somewhat obnoxious that we can't. Yeah. I guess I can just... It's slightly annoying that I have to have the mask be flat like this. But I can probably just do self dot controlled agent mask of num equals dx. This is mask, not controlled agent mask. I think that's good. Now, the other thing I could do that would be cleaner, I could do agent mask and then self.mask equals without the clone. This is a nice trick, actually. I use this all over in my Python code, so this will be useful for people. So you make right here, you make this copy of the mask. And now this is not a copy, this is a view. So we have a structured one and we have a flat one. And what that means is I can go up here and I can do self.live agent mask of terminal is equal to 0. This is the structured one. And then I can go down here and I can do self.live agent mask. And I don't need any of this logic anymore. I just need IDX. So this is substantially cleaner. I no longer have to do this. Look how nice that is. And we return self.mask, which is the flat one. It's a nice trick. Tensors used as indices must be of a specific data type. Bool. Subtraction with a bool operator. There's code that I didn't write. I did not write this code. Cannot convert float infinity to integer. Assuming that the mask is empty here. Torch.sum mask. I'm assuming that there's no data. Is it no data in reset? Wait. Self.mask. Let's see what the mask says. Okay, so we have some agents, right? Then reset. And we return reasonable stuff, don't we? I'm assuming that this is because global step is 0, right? Okay. I mean, I can tell why this is. Torch.where. This needs to be a NumPy array. I don't know why it doesn't know the API for this. See this? Now, this broke my terminal again. Input must be tensor. Not ND array. Don't need dot item. Cool. It is impossible that the steps per second is the same as before, though. So that's an issue. Point. Yeah, look at that data density. Less than 10% is actual data. Most of it's just padding. Oh. Hello, YouTube folks. Welcome. We're making some progress on this. For folks who just got here, this is the GPU drive environment from Eugene's group at NYU. It is a high-performance GPU simulator for driving. We're currently attempting to add support in Puffer. I keep running into all sorts of low-level issues. This is the first GPU-accelerated environment I'm adding to Puffer. I tried to actually add a CPU version of this, but I ran into issues. Puffer's whole stack is really optimized for CPU, but nowadays we actually do have a fair number of nice general-purpose tools, so I thought that it would be good to add in anyways. So today the goal is to have some sort of reasonable binding for this, and to have some automated experiments running that will find us good policies for driving, with like nicely tracked metrics and all of Puffer's quality of life stuff, plus carbs hyperparameter sweeps. So we do have that nice hyperparameter integration, and we're going to see how well it does. We have a few issues that we're kind of going back and forth on here. They've been pretty good on replies. I mean, I really haven't had many big issues with this project specifically. The main issues have just been from the underlying Madrona engine that they use being a total pain. But, you know, we will get there. No worries. Okay, so the next thing I need to figure out is why the global step is not being incremented in the way I expect. This should be 168. Okay, some agents die, right? It goes back up. The fact it goes up that high is weird. Is this possible? Yeah, okay, so that's got to be a bug, right? The reason that it's fast is because it's saying that we have good data density, but that can't possibly be the case. I probably just borked the reset call, right? Because this should actually be hurting. Yeah, right here. So this live agent mask is wrong. This is self.controlled agent mask of IDX. Yeah. Okay, now we get something way more reasonable right here. You can see that agents die, agents spawn back in, but it stays in the range of like the original data steps. Unfortunately, it also means it's going to be incredibly inefficient. But they have told me that there are ways to make the simulator return better quality data. We might have to reduce the batch size a lot. Yeah, all the way from 60,000 steps per second down to 2,000 steps per second. And all the time still in the environment. We could try to do some hyperparam sweeps, but this is so ridiculously slow. We could try with very small batch sizes, I guess, and just hope that the sim is not that hard to solve. I think I'd like to... Let's see if we can at least do some level of optimization here. I should be able to get... I think I should be able to get a free, like, 4x improvement. Maybe 8x. Let me open... I have, like, DMs on this. Where's my window? Okay, they say they get 50,000. So I'm going to just tell them the numbers. Oops. Oh, great. I have, okay, cool. Lots of support from the team. That's awesome to see. Not going to show the DMs, but, yeah, very nice. Yeah, I see that they say I probably have some bugs, which is expected. This is a brand new port. I can show this. So, looks like maybe a bug since they have a value of 8.0. I think it's a sum instead of a mean or something like that. That should be them adding me to the Slack so that they can help with the CUDA bugs, and then we should be well on our way. We should be well on our way. Let me go grab my work email. Hold on. And then I will just basically be, while I'm deving this, I'll be on the side chatting back and forth, seeing if I can get the CUDA stuff debugged. Don't have any invites yet. So we'll see. Oh, there it is. Continue. Joining their Slack, and hopefully they will help us get CUDA support for the environment. Shared channels. You actually have to upgrade in order to frickin'... That's obnoxious. I mean, I'll do that if I need to. Slack is such garbageware. That's fine. I'm sure I'll forget to cancel this forever, but whatever. Like, unironically, I just want all the freaking stuff to just be done on Discord. That'll be funny. Oh yeah, join the Discord. So the plan for this is once we get once we sort of, we'll go back and forth on CUDA, and once we have that, we will be able to get this running a little faster. But in the meantime, sort of while I'm messaging here back and forth, unless we get going on that too much, I'm going to try to optimize the data density a little bit, because they have the identical problem that I ran into for years with Neural MMO, and it's a killer. Like, it will actually kill all of your research because it just makes it too slow to be usable. So they say that their sim runs at 1,000,000 plus, but they only train at 50K. We need to get them training at several 100K. Come on, Slack. Worst possible application. Does anybody actually like Slack that uses it? I remember it used to not be bad, and it's just gotten worse and worse. I guess the same is true for a lot of stuff. Discord used to be better as well. Required 2FA? Get out of here. Heaven forbid somebody hack my open source research channels. Holy hell, the amount of stuff that they make you do in order to just use their bad software is crazy. Hey. There we go. Yay. I actually can do this now. I'm intentionally on the side screen here just because DMs. But as soon as I get this set up... Cool. While we're doing that, let me pull up the notes that I got from Daphne on how to make this thing faster. So, it says to set roadmap obs false, k max observation count. Yeah. So we got k max observation count. Let's go set that. What do I want to set it to? That's the number of road points. Oh, wait, that's just observation size. We want to do... What we want to do is we want to add... We want to make the simulator return us less dense data. Okay. So, I was told that if you just go into this GPU drive, it should be in consts, HPP. But I tried messing with this before. Is that Pablo? Wait, I don't like it, neither do I use it. Okay, I thought that was different Pablo. Maybe it is. Um, Unfortunately, Slack is one of those things that just crops up repeatedly, where like you're essentially forced to use it because somebody's going to need to use it. It's fine though. It works for now. Where's the Slack? So I can make sure I keep that window open at least. Okay. Now, I was told to reduce this Kmax agent count thing here. So if I like reduce this to 32, and then I was also told to do to reduce this potentially. So let's do this to 64. This is good, right? And then we recompile. Where's the recompilation? Okay. Let's see if this gives me the same data shapes as before. Good. This gives me different data shapes. PufferLib, environments, GPU drive. And can I set this to 32 now? Roadmap agent feet dim. Is this, hold on, I might have hard-coded that somewhere. Is it top K road points? I think this is supposed to be 64 now. Shape is invalid. For size. This just not save? No, this is a legitimate error. Let's see. So we've got unpack obs somewhere. And then this is on line 36. .512 by 1142. Roadmap agent feature dim. Oh, max controlled vehicles is just set wrong. That's fine. This is 32. And now this should work. Nice. So that is a free 4x speed up. And also, it's probably going to be faster than 4x because we're now using very, very suboptimal batch sizes. So let's fix that. So 32 by 16. Normally, my rule of thumb is 4096 batch size, but we're going to go a little more. Yeah, 512 is definitely too low. So let's go to 32. Let's see if this is faster. It should be. Yep. We're now at 10K. That's 10K real throughput. And can we do 64? Yep, that's 12K. It's a little bit faster. And 128. This is normally where I cap out, as I do 4096 batch size, which is what this is. And we'll double it one more time just to see. 15K. Okay, this one is this is probably a bit much. It's slightly faster, but that's a lot of data, so we'll leave it at 128. Okay. That's a little bit more reasonable. Now, of course, as soon as this env is on GPU itself, this whole thing will skyrocket. Do we have a reply on here? Let me see. Nope. I think Eugene said he doesn't think it's 12.2. Let me double check. I'm pretty sure. Whoops. What's the window key to restore all your tabs? I hate that it does that. Who thought that that was a good feature? Yeah, so Eugene says he does not think it is a CUDA 12 issue, which would make sense. I don't think it should be either. So really the two things at the moment are Madrona and whether we have decent metrics. So I don't know, let's do we want to just track a run real quick? Well, we're not doing a 10 billion step run. That not even close. 2 million? 5 million? So we can see if it actually does anything over time. And I'll pull up wand B. They say their sim runs well over 1 million. Training definitely needs to be faster. Training definitely needs to be faster. Okay, so here's steps per second. And we get mean reward per episode, which looks like it increases. I think vehicle collision should go down, right? Looks kind of unstable. We can throw a carb sweep at this thing, which is going to be the plan. Oh yeah, it goes up. It goes up. This is not really going down, though. Goal achieved isn't either. So we'll see what their train curves look like. Any replies on this? Nope. This flattens out very quickly. I mean, there are lots of things that we can change here, though. The main thing is just this is not a usable steps per second. This has to be much higher. Like 80% time in the end? No. I'm trying to think what we can do. Is there anything we can do to, like, that I haven't thought of to get Madrona working? Oh, I totally missed Pablo's message. I'm not anyway. Yeah, okay. I thought it was a different Pablo. No worries. I have way too many windows open today because of all the DMs and stuff. I'm just trying not to miss, like, Slack messages that might be them fixing stuff. This is a nice set of curves, though. Reward goes up. It looks like it might be crashing now. Entropy is good, though. No, we're good. It was just a temporary hiccup, it looks like. Right? Yeah. So interesting that this goal achieved metric doesn't go up, but reward does. I don't want to read too much into this before I fix up all the settings, though. For sure. We also probably want a data density metric. We should probably add data density. Let's go ahead and do that right now. Self.controlled agent mask. Jeez, that is not what we want. .sum.item divided by num worlds divided by num objects. So this is going to tell us how much data we're actually getting that is real data. This is an important metric. Did this thing level out? Yeah, it leveled out. We're good. It's nice and stable. I assume vehicle collisions are supposed to be going down and stuff, though. Yeah, definitely. There's also the K unique scenes thing. I'll probably need to edit that. I mean, really the thing I want to do is I want to have Madrona working. I think why it wouldn't work on GPU. Like, I have CUDA 12.1. Oops. I missed something? No, I didn't miss anything. Did I like do anything stupid? Is there... No attribute close. Okay, let's fix that as well. I forgot to do that. This will give us data density. Oops. Def close. Okay, so we have a full run, though, basically, of a GPU drive. And you can see this point at the end. This is the puffers, like, it does a good estimate at the very end for you. Controlled mask sum. Okay, I typoed something. Controlled agent mask dot sum dot item. And now we get data density. Okay, so this is very bad right here. This is 34% data density. And actually it's worse than that because it's actually, it's supposed to be live agent mask, which is self.mask.mask.sum, which is, yeah, like this. So it's probably worse than this. Probably starts at point. Oof. That is rough. Holy. Jeez. 10% data density is, like, unusable. So if they actually have... The funny thing is if actually right now, even on CPU, we can match their train steps per second on GPU if we had dense data. Which they said that there would be a way to do that, potentially. But for now, I think we can still get substantially better if we just get the darn env to run faster. Yeah, because there's also a little bit of MISC, bandwidth transfer, and other stuff that we got to optimize. Finished agents. Do we just load up policy, maybe? We just do mode eval. Ugh. I think that this is using the wrong vec, right? Because right now I think I like wrap it in a serial or something. Config, profile. Oh no, it's right here. So env creator, agent creator. Am I missing messages? Oh, I am missing messages. Cool. Where does it make the env? Right here? Let's do backend. And we'll do backend. Vim. We do need to do vec backend here, don't we? Moderately annoying. I have to add the eval here. And we'll come up with a cleaner way of doing that later. But can I do this? No attribute render mode. Just have to define some stuff, right? Does it have a dot render method? Yeah, it does. So I think RGB array. Dot render RGB array. Qt. Okay, they use Pygame for rendering, and it doesn't seem like they have a different backend. I can try to get the Qt backend working through. No, it's not going to work through this. It'll have to be through, it'll have to be local when I render it, which is fine. So I can commit this stuff up, and I can probably get this rendering local. Let's commit all this up, and let's see if we can see some policies locally. Demo. Torch. Oops. Cool. Okay. Get a local term open. Puffer. We don't need that. Okay. We do need to go up to the GPU drive env and change some stuff. Source. I need to change the consts to be, this needs to be 32 agent count, and this needs to be 64 points. Oh, let me give them they asked for a demo of something. Let me give that to them. This is a nice trick that we have in Snake. Let me just make sure I have this is the right file. Snake pointers, snakes. Yeah. Oh, they say that the env internally doesn't have to pad agents. Cool. That's good. They say that they don't actually need to pad internally. This would give you a ton of speed back. We could just implement this straight up, they say. Oh, they actually gave me... Hold on, they have a PR. They says, return to tensor irrespective of the number of agents or number of worlds. Is this what they say this is? Num agents. Clean RL. Haha, they literally have a clean RL version. That's cool. And then this is... batch size. What is self.batch size? N times A? This is a nice PR that they have. They have async reset. Wait, this is funny. Why do they have async reset? Where'd this API come from? This is my Puffer API, isn't it? Ah, okay. One sec, I gotta finish these messages up. Cool. Okay, one second. I gotta do one thing. I'll be right back. All right. So this is funny. They say that this is actually based on Puffer's CleanRL implementation, which is funny. CleanRL. They say their end works. CleanRL part doesn't. I can help with that. So they say that they tried to run Puffer Tank just by pulling it, but they are not getting drivers. I might just give him SSH access to the box I'm using. That would be easiest. This is kind of cool though that they did this based on Puffer's implementation. It's cool to see people starting to use it. Yeah, because they have like the async API and stuff. We'll make that work for them. A lot of good stuff here. I'm trying to think how they... Oh, I actually see what they're doing. Oh, this is easy. Yeah, this is easy. I'll have to do a copy, but I can do it. I can literally implement this for them. It wouldn't be hard. Only thing I can't fix on my own is the CUDA stuff. I don't know what's wrong with the engine. But basically, if they get that portion working, then I can have it be fast enough to run sweeps, do some basic testing there, and then I can do this port for them. As long as I'm not dealing with like crazy CPU threading hell where I'm just like sitting here doing nothing, I'm happy to like keep doing stuff on this. This is good because this is a nice sim. Always have them hop in stream and co-work. Not everybody's comfortable doing that. They can, I mean, they're free to chat from here on stream, but, yeah. I can also just link them the stream, right? Yeah, they can. I can also just link them this stream. So, right, we were trying to do something though before we got distracted here, right? Let's see, because they're gonna have to take a second to do that. So let's actually see if we have any policies trained. GPU drive. Oops, I don't want to lose that tab. So we will recompile. And we'll see whether that is enough. And we'll see if we can run the visualizer. Pip install. Reinstall. Oh, good. I thought I'd forgotten to unmute the mic. Where was the command? GPU drive mode. Vec native. Let's see what this does. Anything? Okay, so this is the compilation not working. You can see that. I think I just broke this installation, right? I might just want to redo the setup. What changes do I have in here? I don't really have anything in here that I need, right? Yeah, no. Don't need any of this. GPU drive. We'll just redo the setup correctly from the puffer fork of it. Grab GPU drive. Cursive. All right, so that'll take a second, and then what we'll do is we'll edit those constants, we'll apply it, we'll sync that to the puffer fork as well. We'll see whether they like the policy as well that I have. Well, we'll see how well it does first, I guess. Usually people are horrified by how simple I make the RL policies, but if you just push more samples through them, it usually evens out or more. Oops. I forgot how slow this is on my local. Well, whatever. It will, oh, there it goes. So we'll set this up. Hopefully this will let us run, and we will be able to see whether the policy is any good. That's the intent. Mm-hmm. I think there was a comment here. Non-vehicle collisions have a value of 8.0. Maybe a bug in your code. I think that they just have mean, so maybe we'll look at that while this is finishing if it takes a second. But it's probably going to finish as soon as I say that. Baselines. This is algorithms. SB3. And I think it's wrappers or callbacks. Yeah, this. So yeah, this right here. This is, they did it as a percentage is all. That's fine. So our stuff is fine. It's just, we probably want to norm it. Otherwise it's going to be like not comparable across different experiment scales. So we'll have to norm that, but for now it is fine. And almost forgot to do the thing that I wanted to do, which is source. Okay, that'll build. And then once this is built, we should be able to run the viz. So things that need to be done right for this to be fast. CUDA, obviously. I don't even think we technically would need CUDA on the environment, but it's either going to be CUDA or figure out how to thread the environment properly. Like, it can't be thrashing a ton of small processes. So I might still mess with that to see if I can get their CPU mode to run fast. Something like that, maybe. But in the meantime, we'll just do the GPU mode. I do think it's conceivable that CPU mode ends up being faster. We'll see how fast their sim is. Because, like, if you're going, like, even if it's 1,000,000 steps per second, you're still wasting a decent chunk of your GPU time. It could be offset by CUDA transfer and other things, but I have found that to be the case before. Maybe for this, since the data is so big, it wouldn't be as big of a deal. Kind of nice to have the data on GPU already. Good and affordable infrastructure. Train some LLM to play Dota 2 or StarCraft. Okay, built. Perfect. So, let's see if this runs now. Right, we have that annoying bug. No big deal. Move, build, flash. Stormgate came out. Basically StarCraft 3. That's cool. For RL purposes, though, like, unless you build the env thinking this has got to be fast for AI, it's not going to be fast for AI. Segfault. Got tensor. Kind of weird how that happened. Huh. I don't know why that actually happens. What do I do in, oh, it's as tensor instead of from NumPy. That's actually really nice. Well, I got rid of the from NumPy call, didn't I? Oh, I did it on the wrong machine. This is not the same box. Does this work? Hey, look at that. The pink cars are neural nets, I think. Is that how it works? Yeah, pink cars are neural nets. And we also have to get the policy that we just trained, right? So, whoops. Why don't we just grab a GPU drive policy? Oh, we didn't get the policy because the run crashed at the very end. Well, it's okay. We can train another one really fast. We only need, it looks like, where is it? Probably we only need like a million steps or whatever. Yeah, a million steps worth of data is good. Vec native. GPU drive. 1 million steps. Track. We'll just do dash dash track like this. Baseline? Yeah, why not? Except it's supposed to be train baseline. Yeah, this is good. So that'll give us a run in a minute or two. A few minutes, I should say. Oh yeah, 1 minute still. It's not bad. Any additional messages from the creators here? Miss anything? This machine. Oh, there they go. They're messaging something. Cool. So we'll have this policy in a second. With not normed, but still may be decent. No luck. Can set up tail scale. Okay. This is now done. So watch how cool this is. If I do dash dash baseline here, GPU drive, is it downloading my policy? Uh-oh. Oh, there it goes. That looks different from before, doesn't it? Doesn't look good, but it looks different. 0.139 is the reward. Is that what we see here? Oh no, because this is per episode. Where's the reward? Is reward not logged? No, we don't log reward. We only log these metrics. Okay. Yeah, you can see that the behavior is different, but not good. It's the pink agents that are the, why do the green ones also fly off the map like that? Well, we have stuff to fix. Let me pull up tail scale. I'm going to add one of the devs to my cluster. Probably don't want to advertise this too widely because we do have limited compute. We were also affected by the Intel chip issue, so we're going to be down a couple of boxes for a couple of weeks most likely. But we do technically do compute sponsorships. for cool open source stuff in this space. Has to be using Puffer, has to be something that we think is like fundamental and good for the space, but we do technically do that. Maybe both green and pink. They said that some of them are supposed to be human agents. How do I invite? Hold on. Machines. There's invite external. Copy invite link. Okay, I deemed him an invite. Cool. Box 7 is sad. So Linky, the plan on those boxes, and you guys have to tell me if you want me to send 7 and 4. But there's an update coming out from Intel in a few weeks, that will, or like a couple of weeks, they said, that should help in combination with tweaking some settings on the CPU and stuff. What they said they're going to do is they're going to adjust the timings, install the update when it's out, test the machine extensively. If it works, they'll ship it back. If it doesn't, they'll swap the CPU. But, you know, they're trying to do limited CPU swaps if they can, because as you can imagine, they have like a huge wave of stuff over this. Because like most of their boxes are Intel, and they have everybody RMAing everything. So we can ship box 7 back, though, for sure. It's just a matter of whether we want to do 4 and 7, because they're going to be out for... If I ship box 4 tomorrow, then they're going to have to hold it until the microcode update comes out. I think you'd rather have it for an extra week. I do need to start buying some more boxes, though, for sure, because we're getting to the point where now I have usage for more as well. Technically, I could buy them right now, but I kind of would prefer to buy them off of revenue from the company, if I can. So I'd like to start on that first. Hold out on 4. Yeah. Okay. Ask if, yeah, they said that they'll throw the BIOS update on it when that comes out. But like I'm not there in person to do that update. So I can't have them ship it back and then do the update myself. I can't do it remotely. Okay, so we're about to get this this guy onto one of the boxes. Is this puffer box 1? It is, right? Yeah. Does it get you right into the container when you log in? Yeah, it does. Cool. So he should be all set up. We can get this started. So they have, oh, that's interesting. They say blue is human replay and pink is policy controlled. Is this actually downloading the policy is the question? One data is saved locally. Oh no, I see now the file's downloaded. Seg faults. Well, this is weird, right? So it goes off the road over there. I think these might both actually be neural net controlled then. I don't know why they always look like this one is slow though. Why it's sometimes seg faults as well. Is this actually loading correctly? Probability tensor. Oh, I think that's yeah, there's a local update I need to push. High GPU and torch source constants. What? This should be a fork. I forked it, didn't I? I could have sworn I forked it. Hmm. GPU drive. I think I remember that it was... The only thing I did in here was I added these lines. Let's do that. Pi GPU drive and torch and 147-ish ego states on equals. Oh, it's not equals 0. Whoop, they're having difficulty logging in. Let me see. Tail scale. Let's see if it sees that they... Users. I should see 38. Let's just fix this in the meantime while they figure that out. Cool. So that was all we needed here. And I should now be able to run this without seg faults. Linky, are you there? Was that, remember that issue where it would log you into the, like, your own tailnet instead of mine? Damn it. Credentialing bullshit. Make sure you're on the right network, yeah. Do not see him. I see the user added. I don't see the machine though. I can see that they have no machines. He's got yeah. Need to log into Tailscale and then use the email link, yeah. Oh, look at that. Ah, I got it. Whoa, 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 whoa. It actually did it. You see that? It did get it there. It got there the one time. I just saw it do it. Cool, though. So, this works. Did this just make me a GIF? Or did it just break my terminal? Docker eval gif. Maybe I've got something. Puffer tank. Hey, look at that. I bet it's getting masked wrong because it does it the first time. Let's see if it works for him. I don't know why Tailscale does that, where it's like so easy to log in by mistake. Cool gift though. Drives better than I do. Okay, cool. He's got access. We are right here. I'm gonna make this easy for him. Then it should just be cool. Great. Now we've got their dev on the box looking at this, which is great. This is the one thing I do not know how to fix. I can technically start a little hyperparameter sweep in the meantime, right? Might be a decent thing to do for them. No, because they're going to be messing with the compiled file. Yeah, that's okay. Let's see what is up with the reward and such. Let's see what's up with the reward and such. Go look at the SP3 wrapper for it. Set up discrete actions. Well, first of all, these spaces don't match. So I think they did something different here. They do have this nice script. But I want to check the SP3 one. Log first to 95. So yeah, it should be goal achieved should be increasing. And the fact that it isn't means that it's probably not training particularly well. It's odd because definitely odd. Am I doing the masking backwards or something? No, how would the reward be going up? That doesn't make any sense. My bet is on something with the data being wrong, though. Rewards going up, but none of the other metrics are going up. Maybe I can extract something from wand B here. Let me see the losses. What? Where are my losses? How are there no losses? That's bizarre. Okay, do I have a better run before that with losses? Not this one. There was a 5 mil run. This one? No, I don't know why there are no loss panels. Should be losses. I think it needs development versions of CUDA. Oh. Oh. Gee. That's annoying. They need the development. They say they need CUDA dev. I would not have thought of that. Let me see. Yeah. Dang, I gotta update the base container for this. Let me see if the PyTorch base containers are any good. .8 GB. And then NVIDIA CUDA base containers. They've got runtime devel. I want 12.1, right? Yeah. Like, did they only have 12.5? How the heck are they deprecating stuff so damn quickly? 20, then they have Ubuntu 22. And they just actually updated to 2404, which is really nice. I have to get a 12.2 base as well, it looks like. What CUDA do they support? Guess today is going to be Infra and DevOps day. They have local CUDA 12.12. Okay. It's so weird that they only have latest and then they go to unsupported and like they immediately are deprecating. Six months after the last supported driver has gone end of life. It should be fine. 12.2 is, this is what we want. So I guess we're going to just do this inside of this box, huh? Why is the tag structure totally different? Not sure about Torch versions. Jeez. Too much update. Okay. Docker. So what we're going to do here, we're going to edit the Docker files to be the latest versions. I don't know what's happened. Like, they've changed all of their... Oh, they just changed their naming convention is all. Yeah, this is fine. They just changed their naming conventions. 12.1 runtime Ubuntu. Yeah, this is fine. So we want this. We'll go right like this. Here. Boom. Okay. We got the Debian front end. We got Python 3.11. We got pip. And then I think this is out of date, isn't it? Hold on. Oh. Ooh, yeah, that's old. This is very old. Oh. Check out 1.0. Get this. This is fine. Is my mic picking up background noise? Doesn't look like it. Anything greater than... Okay. They say they say that this should work. I'm going to trust them that this will work. Let's get CUDA here. Python pip. Run. Torch vision. We don't want this one. This is 12.4. We want 12.1. That was almost bad. Okay. So this will be our new base container. Image is base. Base. Wait, image name is... Hold on, it's... username slash... Yeah, it should be base. Base, like this, right? We'll just update this in place. -d base. Okay, so there we go. And I'm actually going to even put their environment into the new container so that it's like first class support. It'll be easier for people to get it. It's not that bad. I think the second stage build is the one that's always a pain. So, but it'll be cacheable. And I think the CMake version works as well. So we don't have to deal with that, which is nice. Yeah. It shouldn't be that bad. Sanity video. Bona multi. Very exciting world of rebuilding Docker images. People have been asking me to do 2.4 for a while though. I don't think there was any, did the Pokemon project need anything else, Linky? In the base containers? I think that guy just wanted 2.4. I know that they wanted upgraded Ubuntu, but that's not going to happen just yet. NVIDIA's updated their new containers, but it's not going to happen until we have PyTorch with CUDA 12.5. Then we can get a upgraded Ubuntu as a base. And it's very likely that's going to break a bunch of stuff and take some time to fix. .04 is fine for now. All right. Yeah, I think there's going to be some breaking changes as well when we get really recent versions of Python with some of the older environments. Like this is the year that like a lot of people just straight up move to language models and stop maintaining stuff entirely. So most of us run bare metal except for the boxes. Boxes are there for a reason. The puffer tank containers are very nice. You literally get an identical setup to the boxes locally for free. Any nice simple env you want to add to Puffer so I can get some practice. Thinking of Tetris if no one is making it yet. So Noah was doing Breakout. You can do Tetris. I think Tetris should be a pretty easy env to make, right? Because like you can do pixel observations, but also the state is technically a grid. Linky, the containers don't take your RAM like that. They're very thin. Tetris would be cool. I think Tetris would be on the easier side as well. There's some other M's that we definitely want, but are going to be harder to do with a grid. Like, I imagine that, like, some of the Atari M's, right, are going to be harder to do. Even something as basic as Pong is going to be slightly annoying to do on a grid. Like, I know how to do Pong on a grid. It's just slightly annoying. Requires a little discretization tech. Tetris would definitely be cool, though. Let me think if there's anything wrong with that. No, I think Tetris should be pretty straightforward. Tetris is pretty straightforward. I have Tetris working in Atari as well, like the Atari Tetris. Grid, you mean for rendering or obs? Well, you can render whatever you want, but the observations, like, if you don't want to have, you want to have an image option probably, but you also want to have an option to do. Why use a grid for Pong? What state would you suggest? You could technically come up with some like featureization of where the ball is and where the paddle is, I guess. That would probably also work just fine. Most of these environments, you can probably do that. As long as you're not wanting to train on multiple at the same time. Some normalized relative position. Yeah, you could do that. It'd be cool if we could come up with some like universal way of representing all the Atari M's that doesn't require us to render to pixels, but what compatibility will break updating to higher Python? Older versions of Gym, older environments that don't have packages exported, like ProcGen I think has annoying stuff. Yeah, a lot of things. All right, well this is our Docker build. Torch. That's for CUDA. Yeah, we got CUDA. This image is deprecated and scheduled for deletion. Dude, why are they deprecating stuff that's like this? Like, they're deprecating stuff way too quickly. I don't know what they're doing. Username, name. Let me go figure this out. Cool, we'll give it a go. Yeah, Tetris is good. Tetris is nice because it has a really obvious grid representation for the state, right? So you don't have to think very much. Thinking is hard. I advise avoiding it whenever you can. Look at that. Isn't that nice? Update the Docker. So that's stage 1 of the build. Once this is done, we'll start on stage 2. And then stage 3 is quick after that. Well, that'll get us a proper version of Torch at least. And looks like it will probably increase the image size a bit with the dev stuff for CUDA, but it's okay. Eventually, I'd like to get a more minimal image, but it's just so hard with all the M's we support. It's like the one thing I had to compromise on. Like, I can get everything else, but I can't get the image size to be more reasonable. It's not bad if you have a gigabit, like gigabit Ethernet or whatever, but it's pretty bad otherwise. Speed will be much faster than this. Go to affordable infra. Oh, this is Kenjun, okay. Poor guy's doing front end. I don't feel too bad because Cursor's writing all the code for him. Shish. I probably should have gotten a gigabit up as well for the cluster, don't you think? I can probably start this though. I can start the next build while I'm waiting. All right, let's go. Depths. This is the second stage of the build. It goes from base 1.0. NeoVim and Vim plug, go there. I would like to put it above this, but I know that that portion is slow. So what we're going to do instead is we're going to clone their repo, my fork of the repo, so I have easier control over updates. We'll keep this in sync. I don't know how that just happened. And then we do their install stuff, right? Okay, make their build. And I need to get the Python flag here. What's the Python flag that I should probably do for this? Thread is so old. Oh, this has to be find Python 3. Okay. We'll just not do that for now. I think this does it. And we'll just do I need to go find the path. Where's the other Python window? Build. Where did this go? Okay, so you make .j. Move this file. So, and cd dot dot and pip install -e dot. That's good, right? Not sure. Oh, hello. I see you're in the live stream now. I'm just renaming this thing for now because I'm going to have to redo this every time I build the container. Also, I don't know if you guys have looked at this, but it's kind of annoying to get the GPU drive environment working outside of the directory where it's installed. You need a symlink. So like I have, if you look in PufferLib, I've got this PyGPU drive link. It's GPU. So I think we got to do cd dot dot PyGPU drive. Is that the right syntax? Let's see. Path to folder to be linked, which is okay. I have it backwards. No, wait. The folder to be linked is PyG. Yeah, I have it right. Okay. So this looks good. So then this is, ooh, what is this called? Is this puffer depths? I check our Docker hub. Docker. Unfamiliar with manually. Well, the thing is that pip should do it. I use the pip install and it doesn't link it. Are you sure that Poetry does that for you? Because in the example scripts you have some stuff that has to manually change dir in order to get the paths right. So that was why I had to in this case. Docker. I really like their pufferfish icon here. Why can't I see Puffer AI on here? It should be here, right? Jesus. That's so screwy how you can't see your own stuff on Docker Hub. It's like all these it's all the way at the bottom of the page underneath all like the verified whatevers. Mm-hmm. Tags. Oh, no. There should be multiple things under here though. Puffer dash depths. Cool. Oh, this is not gonna work. Wait. I'm dumb. Yeah. Poetry has a con. Yeah. So I don't use conda because it's redundant inside of a Docker, right? Having virtualization plus Docker is just like nutty. So I do everything is managed. Everything is bare, but it's inside of containers. That workflow has been ridiculously effective for me with Puffer, because if something goes wrong, I don't have to rebuild the whole environment, right? It's literally 5 seconds to nuke a container and remake a new one. Not to mention it gives me a consistent dev environment locally and on server. Oh, there it goes. Okay, this is pushed. So now I can actually build this because it'll pull from the correct. It should pull from online correctly, I would hope. I will be right back. Going to use the restroom. This will build, and then we'll upload this, and the last stage build is really fast. Thank you, Linky. Almost done with this, and if this works, we'll have out-of-the-box puffer integration with GPU drive. You'll just be able to grab the container and you have it all set up, pre-compiled and everything. That's why Docker is really nice. Well, there it goes. That's just on NeoVim now. One of the benefits of being the author of the container is that I get to put my own personal config in there. And you can change it if you like, but that's the default. Good question is going to be why training is getting stuck. It's possible I'm doing the masking wrong. It's possible the scale is just too small. It's possible we need better hypers. Lots of things possible. Fairly reasonable architecture. I replaced the default network, which is kind of clunky, with a simpler version of it. It's got the same three encoder structure. Carbs? Yeah, we're gonna run carbs. We'll run carbs. How's GPU drive coming along? We hit a bunch of infra stuff, but I think we're good now. We'll see whether Madrona works once this compiles. We are rebuilding all the puffer tanks, and we're kind of pushing a silent puffer tank update, which should be non-breaking. Should be. It will contain PyTorch 2.4 instead of 2.4 dev. Hold on. Failed to complete source directory slash I didn't CD into it. That's fine, it's cached. It's cached. We use you use 2.4 already, but you use a dev branch by default in the containers. So this is just going to be the full release 2.4. CUDA goes from 12.1 to 12.2, and that's about it. Are you running it on GPU with Puffer? Yes, I've been forced to run it on GPU. Well, I'm attempting to run it on GPU, and I've been forced to because we could not find a way to disable multi-threading in in Madrona. If we could find a way to get single thread working in Madrona, it's possible that we could be faster. It's possible. That will depend on some other factors. But for now, I got sick of that. I spent all day on that yesterday. I couldn't get it to work. So now instead, we're going to get it to work with the GPU. We're going to focus on just getting hyperparam sweeps, getting, the day 2 integration so this doesn't drag on any longer. And people already will have, within 48 hours, a very nice way of using this project with Puffer, with all of our nice monitoring tools, with hyperparameter sweeps, and, all the other things that are difficult to get with the current SB3 baseline. Not to mention we get LSTM support as well, which they don't have. We get an LSTM policy. Cars should probably be able to remember stuff. All right. That's actually compiling now. We'll see if... every time this fails, this whole stage has to redo. So hopefully I got it right this time. Triton 3. I did not manually change Triton. If it comes with Triton 3 now, it comes with Triton 3 now. I do not know about Triton. Okay, perfect. This actually built. That's incredibly nice. So push. And this is a smaller, it looks like. So perfect. That'll work its way up. And then what's the last stage right now? Puffertank.docker file. This is fine, right? Yeah. Annoys me that I don't have the pufferfish prompt on my stream. It just shows up as a undefined character. Works on most terminals. Windows one doesn't. I don't know why. Windows. I seriously hope that this makes Madrona work. There's not any way to test it, like, easily, right? No, I think we'll just have to hope it works. Yeah. If this doesn't work, I don't know what will, though. Oh, the other thing is we got the CUDA development build. Apparently that was the thing. It wasn't even that we needed 12.2 necessarily, though maybe we did. It was that we probably needed the development build. I'm hoping that's the issue. I have no idea what else it would possibly be, because we'll have everything at this point. Yeah, this is the thing I'm also worried about. Is it's basically outputting slop and then being trained on slop. How long would it take us to run a decent sweep of this? We should also just open their paper, right? That would be a useful thing to do while we wait for this. So they have paper. Yeah, Linky. So over 1 million agent steps per second. Yeah. 512 worlds. Linear scaling up to 128 worlds. Interesting. End-to-end speed, 10 million steps. And they say that they actually get 1E7 is 10 million. So they looks like they have to train for like 10 million steps. So we need to do a few million step runs. Okay. Possibly lower. We'll see. Okay, this is now done. Now what we have to do is docker shell. And this is now a puffer tank. Let me check one thing first. This isn't the one that I had 2 days ago. Ten seconds. Ah, shoot. There was a thing here, wasn't there? I thought there was a thing here. Puffer tank. Image tag name. Oh. Okay, good. I was just making sure I didn't have stuff on here that I was worried about. Status. Nope, nothing. All right. Good thing I checked. Pretty fast build. It should just have to run the pip install. And then we'll upload this and we'll be done. Well, hoping that Madrona works. Puffer's got a lot of dependencies. That's got to be fixed. But I think this is the common option that installs literally everything, so that's fine. Looks fascinating. I wish I understood it. Me too, man. I wish I understood what was going on right now, too. What we're attempting to do at the moment is we're attempting to adjust some of our infrastructure so that we can run this GPU driving simulator, which is really cool. Just came out yesterday. So here's this GPU driving sim. We're trying to run this properly, but it's not launching in GPU mode. So I'm currently trying to fix that and trying to make it easy to use in PufferLib. And then I'm going to try to train some neural networks to drive these cars really well. And we're going to use some automated algorithms to train like 100 different neural networks differently to drive cars, and we're going to see which one does the best. And it's all going to happen super fast and automatically with very, very simple code. Yeah. This is like some of what I normally do is I add like existing EMs. I also build my own EMs. I do a lot of like simulation engineering, mostly more for game EMs, but we're branching out on there for sure. Few other things as well. Mostly just trying to make reinforcement learning fast and easy. I do multi-agent stuff. I do like massively multi-agent stuff very often. We currently have like a miniature version of Dota that I'm building that runs at like 1,000,000 FPS. Yeah, lots of stuff in this area. But every so often stuff gets kind of slow and we end up just being like waiting around on Docker builds and stuff. So, a couple slow days. Pretty much once we have this done though, and once we have a few other things around Puffer fixed, like all the experimental setup for everything is just about to the point where we can automate it. This will be the last layer of the build. So after this will be set. What about their paper? So, wall clock seconds. 10,000 seconds is still too slow. 10,000 seconds is still way too slow. Oh no, they don't take 10,000 seconds. They take like, I mean, this is still like 20 minutes or whatever. It's still too slow. I'm gonna make this faster. An appendix on this. Kinematics bicycle model. Interesting. They got hyperparameters. 30 minutes. Do you know what it's 30 minutes for? Like, is that... I can't tell because it says 10 tasks. Is it 30 minutes for 10 million steps, or like... Daphne told me it was 50,000 train steps per second after you account correctly for padding. Is that right? If so, and if the env is actually... like, it's over 1,000,000 steps per second of dense data as well, right? Is what the environment can produce. Because if we can get over 1,000,000 steps per second of dense data out of the environment, like the standard training in PufferLib, like for our newer environments, we train at 500,000 to 1,000,000 steps per second. Pretty standard. So goal would be an order of magnitude faster than what you have now. Some agents won't reach. Yeah, that's fine. But like you have numbers on here that are like and it's goal reaching. Like I don't know what the task is for this as well, because like I don't know what subset of the environments this is with. Like there are a lot of different environments, some of which are easy and some of which are hard, right? Um like I'd really like to see what happens if we do like a big hyperparameter sweep on this and we get some really nice hyperparameters and then we run it for like 1,000,000,000 steps or 10 billion steps. If the environment is fast enough to produce the data, it would be nice. Hey, look at this. CPU with PufferLib. Haha. No. We got decent we got decent perf out of it. I didn't spend that long on it. That's funny. Oh, you did cite the thing. Why, thank you. Very kind of you. Just the types of observations you can use. You can control radius obs, LiDAR, and view cone. Cool. Are there like hard tasks that are unsolved in this? Or is it like, yeah, we made this really fast and then we trained it and it reaches all the goals? Like, is there anything unsolved here, or is it now like a matter of let's make it like super, super fast and stable and all of that? Cool, this works now. And VCC is still not found. Some agents cannot reach their goals ever. I see. Well, we'll still get some cool stuff going out of this. I'm a little bit concerned that we still don't have NVCC. We installed the dev build as well. This has got to not be the right container, right? Wait. No, we have 12.2, but where did GPU drive go? That doesn't make any sense. We installed GPU drive, didn't we? Oh, darn it. I did it in the root directory. Try our best to remove such agents. Mm-hmm. I'm gonna have to rebuild this thing, aren't I? Maybe this is good enough for now, though. Wait, what? Update your drivers. You realize that this is a Debian server, right? Yeah, I know. Yeah, you realize this is a Debian server, right? Check out dev. Okay. To get 535, I already had to do a bunch of annoying stuff with experimental. I'm not going to remotely brick all these machines by screwing with the base system installs. Base package maintenance is for when I'm there in person. It's incredibly easy. Like I've managed to like actually brick the machines to the point where I've had to like recover outside of boot. So, yeah, you got to be careful. It's not as trivial as you would think. I actually somewhat regret Debian for that reason. I don't think it's a huge difference, but yeah, it's moderately annoying that they're not that quick to add the drivers. But I don't colo. Well, they're not co-located. They're just in a garage that I'm not in at the moment, right? They're not in a facility. I'm enjoying California for the summer. Hmm. Wait. No module GPU drive. Why is there no TOML? I'm incredibly confused. What happened? There's a TOML in here. I don't understand what the hell just happened with this, so let's just recursive. Can you... Oh, I missed this message from before. Can you find... Yeah, 1 second. Find... Nothing found. Nah. I have CUDA 12. Oddly, I also have CUDA. Not installed. Well, we'll see if this is enough or if I have the wrong base. I'd hope not. So this is fixed. GPU drive. I'm gonna get this to install. We're gonna try it. And after that, I'm gonna take like 5 minutes to go make myself a shake. And then I will continue with this. I usually continue. I work on this until like 7:30 usually. Okay. This is built. Okay, this looks reasonable. My run command. Right. I thought I'd pushed that change. I thought I pushed minor fixes. Annoying. Can I actually just do that real quick? Okay, that's pushed. Let's redo their build. I don't understand why it is. Is there no make clean? Let's fix this. Redo the build. Course again. At least I know I'm getting the right file. Okay, so this is CPU. Matches what we had before. I gotta turn on my Super Maven as well. Not compiled with CUDA support. Damn it. So no NVCC with the base. Here, let me push the new. Do I not have this here? There we go. Disheartening. Should be able to build with one of NVIDIA's images. This is one of NVIDIA's images. Here, I'll show you the base. You can tell me if it looks reasonable. If not, we'll work on this tomorrow. But yeah, that's rough. It's very rough. Especially considering I'll have to redo the whole 3-stage build. But here, this is the Docker file for you. It's in here. You can look at this whole repo if you want. So I'll paste the repo and then I'll show you the immediate Docker file. Let's see if you see anything. If not, we'll just call it. Where's the base? I mean, I can still run a sweep of some type, maybe. But yeah, so it's NVCR.io, NVIDIA CUDA. No, hold on. I just committed this. How is this the same? That's not possible. What? I literally see in the container. How is this possible? I saw 12.2 in the container. What happened with the base? Oh, I have CUDA 12.1, not CUDA 12.2. How the hell did I do that? Well, shit. I remember I put this link in. It must have not gotten synced. But I have CUDA 12.2 in the container. Yeah. .2. That's weird, right? But there's no NVCC, so it must actually be the runtime. Well, I will fix that. I will probably have to rebuild that. That's fine. I will do that. That's my mess up, so I'll do that. We'll see if that fixes it. Hopefully. And if not, then we'll figure out what we do. I know it's late in New York. Yeah, yeah, just CUDA things. I'll try to post in the Slack. I'll try to remember to post in the Slack if I get it working. Um, I got like another probably 2-3 hours on this. So hopefully I get it working by then. And I can start running like hyperparam sweeps and stuff. That would be really awesome. Anyways, thanks for dropping by and thanks for all the support. I will see you tomorrow. And as for the rest of the folks here, I'm still going to keep working on this. I just need to go take a quick second to make myself a shake before I pass out because I forgot lunch. So I'll be back in like 5 minutes. And then what we'll do is we'll rebuild all of this stuff. Actually, I should rebuild it before I go because then it will be built by the time I get back. So let's do that. Let's get the CUDA dev image. Just Docker. Well, this looks like it actually could very well just be my screw up. Yeah, this is what I got as it got 12.2. I remember copying this in. I don't know how it didn't save. Right? Okay. Well, yeah, it doesn't have it locally, so it must be new. Well, my bad, I guess. I'll let this build. I'm gonna go grab a quick shake. I'll be back with that in a minute. All right. Ah. Yeah. Perfect. Good timing. It's doing the last stage of the build right now. Of course, now we got to do the other ones. But I'm hoping this will be enough. I'm hoping. I should also test this one because it's possible that we get version compatibility bullshit. And we also want to make sure we actually have NVCC. Why do I not see myself on the stream list? It should show me as live, right? That's weird. Yeah, it says live. With carbs, did you ever run into unable to generate rand? Yep. Yep, that happens. Do you have... Are your bounds impossible? Like, do you have, like, min greater than max or something? On specific variables? That's pretty common. First thing to check at the very least. This is funny. I have not refreshed this tab in a long time. 714 to 759. That's nice. Dang, we're actually like... How long till we pass sample factory? 778? Like a week. That's crazy. That is crazy. Puffer to the moon. Absolutely puffer to the moon. I'm hoping that this means we get a wand B carbs integration. Mm-hmm. There we go. So... Oh, I also... Well, I want to make sure I'm not blowing off Discord messages. Error. Puffer tank. Here's my Discord. Docker stop puffer tank. Test. Boom, we got NVCC. Heck yeah. Uh-huh. Let's see. Second stage of the build. Depending, I might be... Yeah, I might be, once this colleague of mine gets home, I might jump off stream early to chat with him, but we'll see. We'll keep on the Docker builds for now. Steps. Because I can also do this on a call. This is like brain dead work. I need to upload this, don't I? Shoot. I forgot about that. I don't think I can even do anything until I upload it because I don't know if it'll grab the right version. Mm-hmm. Cool. So this will be pushed. See if we have any cool stuff in the Puffer Discord. That's another good use of time here. Any questions? This looks like answered. Yep. Breakout env. I already fixed that one. Okay, that's good. Oh, I just saw your stuff, Relu. Search center was outside the bounds. Yep. Did your nested parameters YAML config work with WAN sweep configs? Yes, it did. it was a little tricky. The dev branch has any files now. Train is an invalid parameter. Probably needs to do the nesting correctly. You need to do like parameters of train of parameters of thing. Can we do RL stuff with images with this engine, like agents that learn to draw MNIST? If there is an RL environment where that is a thing, then yes. We have Atari and Procgen and a bajillion other image-based environments, right? We have support for those, and it's faster than pretty much anywhere else that you would use them. It's just slow compared to the ultra-high performance environments that we're doing work with these days. We have Atari training at like 30 to 40,000 steps per second typically, which is like 10x what you get out of the box with SB3. Mm-hmm. It's faster in serial. Wait, hold on. What? Policy. It's faster in serial. It's kind of cool that they're actually doing like 1-to-1 with the Atari env. Good job on dev. Not done pushing yet. Cool thing about streaming all this stuff is like when people write custom environments and they need help getting stuff working and making it fast, I can just do it on stream. Offer is valid for anybody like making puffer ems for like the open source side. So that's basically anyone minus companies doing their own proprietary stuff. There will be support contracts available for that though. Service is more than contracts. This is like a weird scammy account. Is this done yet? Still no? Bah. I am hopeful at least that this will work once we finish this. It's okay if we have a slow day once in a while like this. It's only Wednesday, so I've got Thursday, Friday to get this stuff set up. I might even stream Saturday as well. We'll see. This week is going to be a little different. I am going to be most likely off Monday and even maybe Tuesday of next week. I've got some stuff to do. More on that in a bit. This is also the slowest layer to build and push. But hey, this will be the official puffer container substantially upgraded at least. We no longer have this kind of janky torch branch, and we'll also have the CUDA dev tools in here. So more stuff should compile easily. We also get NVCC, which is nice. I did the runtime just to save space, but probably that wasn't a smart idea for exactly this reason. I wonder, is there anything else we can look at in the meantime? Probably I should have been like doing something with these Atari M's. I find the multitasking very difficult though. We can probably go make ourselves some like optimal configs in the meantime, right? Why not, right? What are we up to today? More stuff with GPU drive. I'm currently rebuilding all the Docker layers, so I'm just realizing that I should probably do something on the side while I am doing this. So why don't we just go get some optimal Atari configs just while we're waiting. This should not be very hard. Long. I'll put this up on my other monitor so I can see when it's done. In the meantime, let's go get some hyperparameters, because we actually ran a whole bunch of good sweeps. I think this is the first one, maybe. This is breakout. Well, we probably have optimal hyperparameters for Pong already by default, right? So maybe we will start here. Hmm. Some of these things probably need to be inherited or whatever, which is obnoxious, but yeah. Ooh. It's kind of gross actually, right? I didn't think about this. Do I want to maybe just like copy the pertinent stuff for now and then I'll figure it out later? Let's do that, otherwise I'm going to drive myself nuts. Episode return. This one here looks good. So this one here, which gets a return of like 60 by the end. Okay. Probably higher. Let's grab this one. Frame skip 4. Repeat action probability 0. Batch size 32K. BPT horizon is 8. Clip coefficient is a little different. Entropy coefficient, little different. GE lambda, be similar. We're actually going to be able to like plot the optimal hyperparameters and stuff for these, which is going to be nice. We're going to be able to do so much good analysis, come to think of it. Oh yeah, there's so much good experimental stuff we can do, now I'm realizing. We're so close. Can you imagine, like, we're going to be able to basically, like, we'll take these 7 environments, right? We'll do these tuned versions. We'll make sure that we get, like, good, high-quality runs out of these. And then we'll see how much better, like, the average hyperparameter set is among these versus, like, using individual sets. Really, we should have a way to, like, upload these params to ini files or something, but, that'll take time. Okay, so this is our breakout params done. Still pushing the image. Here's Beam Rider. Oh, and these are stable runs as well, aren't they? So like oh, this is crazy. Look at this one. There's one that like does really well and then crashes a bunch. That's funny. Do you have a run for Montezuma's? I don't have a run for Montezuma's yet. We can do that though. I think this is the best one right here. Like best consistent run. Oh wait, this is episode length. We didn't do return. Here, let's try this. Is this more stable? Oh yeah, that's way more stable. Look at that. So the best run we see is right here. Let's see the optimal params. 7 minutes for this train run, by the way. That's all it takes. Frame skip 4. Beam. I think that what's going to happen with Montezuma's is it's going to flail around for a bit and maybe eventually learn like the first screen, and that's about it. And then if you want to be like your classic reinforcement learning researcher, you can spend 3 months of your life or more. Actually, I'm sure people have spent much more than that. Like just tuning the heck out of it, trying to just force this dumb thing to work on Montezuma's, which it has no business doing. Well, fair point, Linky. But in that case, I am at the very least letting you script some stuff to get around things. At least a few things. I'm trying to think if Pokemon versus Montezuma's, like... I don't know. The thing is, like, you actually have better access to the, like, the state and stuff. So you can actually, like, reward shape and stuff, whereas Montezuma's, they're just using the score and expecting it to do something. So I don't know what that's supposed to do, but these are also some crazy hyperparameters. Still doing the least amount of scripting, yeah. You're doing well. You're doing very well. Okay, so that's these are params now that we have for BeamRider. Oh, perfect. We just finished this. So this is now pushed. Docker puffer-deps. 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 GPU drive is here, and we wanted to do what was this? Workdir/puffer tank. So I think this is good. We'll see if this is good. Cool. So this is now building. Events are a huge help, yeah. And put this Discord. Whoops, I might be jumping off stream here. Hold on. Let me see. Half hour. Another half hour. How's Qbert? Look at that. That's pretty solid. I don't know, like some of these other ones are probably better though. It's hard to say. I think we'll use this one for now. But I think that like some of these merit much longer sweeps, frankly. Should just like queue each environment up on a puffer box. Or just monopolize the whole puffer cluster with frickin' 7 Atari environments for a day. We'll pick a day and just do a giant sweep. And we'll just solve Atari in a day. It'll be great. Solving Atari in a day with PPO and hyperparameter tuning. The funny thing is, even if I did that, and even if it worked, there would be a ton of salty researchers saying that, oh, you have to use sticky actions even though, you know, they break everything. And, oh, you have to use the same set of hyperparameters for all the environments even though that literally makes no sense. You can't win. But you can. You might not be able to win, but you absolutely can make some really good agents. Absolutely can do that. Qbert. That would actually be so funny if I just like made a baseline where it's like, hey, we train each environment for a day and we beat Soda or whatever, and I just submit that paper to a conference just to see what happens. Because that's totally doable. Like, we'll be able to simulate enough samples. If I just like check how much wall clock training time other algorithms use, I'm pretty sure that we would just beat them because we'd get 10 times the amount of training data just because of the speed difference. Why was that? Wait, was that GAE Lambda real? Where the heck was that GAE Lambda from? There's no way that this... Did I just paste this without realizing it? There's no way that this was the GAE Lambda. I think I screwed up. This is why I need to have this process automated for sure. If I didn't screw up, that's going to be even scarier, though. Holy, that's ridiculous. I have no idea why that's the GAE Lambda. Frickin' 0.14. It's bizarre. For some reason, it's very stable. What's the interpretation of lambda equals 0 again? It's different from discount equal to 1, right, isn't it? Or discount equals 0. Whatever. Okay, clip coefficient 0.2. Clip coefficient is already done. Entropy coefficient. Does it have a higher entropy? No, it's actually... This is the entropy, and then GE lambda is 0.8. This is a much more reasonable value for GE lambda. Why is this already done? This is Qbert. We're in the right file. Gamma is 0.94. It's a very reasonable value. It's kind of funny, though, when you just do these full hyperparameter tuning runs, and it's just like whatever the hyperparameter run tells you is correct, and like you don't rely on your bad intuitions about how things are supposed to work. Purpose, it helps. Yeah, but Linky, that doesn't... I gotta go look at the formulas. That doesn't tell me anything. I know the interpretation at, there's separate interpretations at 0 and 1. I know the interpretation of the discounting factor. I haven't looked at the J lambda in a while. I do know that it tends to be less sensitive than the discount factor. Oh, split. Yeah. I didn't see the message, my bad. Value function clip. Cool. I'm a little suspicious about this frame skip parameter. Oh, did I not sweep it? No, I did. I swept it. If it's always 4 for all m's, though, I'm a little suspicious of that. It seems like sketchy that it would just always be 4 for all m's is the optimal. Gamma's discount. You're probably right, JB. Math is boring. And then like the researchers will tell you, yeah, you're gonna want to set like GAE lambda like below 0.9 makes no sense, and you do the hyperparameter sweep and it sets it to 0.14. Look at this Space Invaders run. This is crazy. Look at that. I guess this is not a particularly good score though for Space Invaders, right? But it's a very nice curve. 5-minute train run. Explained variance does not look good. Oh, wait. I forgot we were building Docker images. Gamma's discount, yep. Failed to solve. Cannot CD to puffertank/GPU drive. Okay. Make dir. Space Invaders. All frame skip 4 is very odd to me. I'll have to make sure I'm actually sweeping that param well. Sounds like a bad linker. Yeah. This clip coefficient is very stable at like 0.2 something. I wonder how sensitive it is though to that. Entropy is actually nice and stable too. I think there's like a little bit of a range for that one. GAE lambda is 0.69. Gamma is 0.99. 0.99 for Space Invaders. I wouldn't think Space Invaders would be a particularly long horizon game, as you just shoot the things, right? Max grad norm. And, mini batch size. It'd be cool if we could find a way to do, like, all of the M's at the same time or something. I don't know. Let's see. M's, workers, time steps. 7. Oops. 7.5 mil. Do. Epochs 4. I don't know why they have so many update epochs as well. They do so many updates on stale data. You'd think you'd want fresh data. But I'm no longer attached to any of my preconceived notions about RL anymore. I just run the experiments, and they simply tell you. Because it's become apparent to me that nobody understands how the hell any of this stuff works. Oh no, failed to solve again? What'd I do? Cannot open shared Google test add. Wait, Google test add tests. What? Oh, error? Interesting. Huh. NVIDIA CUDA toolkit. Is that what I need? Is NVIDIA CUDA toolkit? This is 2018. Let's get something more recent. Some jank bugs. Set the LD. How is this a thing? What the hell? Where's user lib? So what was the error message I had? Can't grep in a container that doesn't exist, Linky. So error while loading libcuda.so.1. It's clearly there. I mean, I guess the easiest thing to do is going to just be to, like, comment all this. And then I'm just going to boot into this, I'll boot into the container and I'll figure out where to fix it on the container. Oh, that's not Linky, that's that guy. What's up? You can run, hold on, let me make sure. You can run ldconfig. Yeah, I'm going to build a partial, that's what I'm doing. There you go. Hey, Linky. It's right there in the normal spot. It's literally right there in the normal spot. So, I guess what we do is we run the... Hold on. What we do is we run the normal... Okay. Git clone. Yo, the container and fix it in YOLO. Oh. We're gonna do something. Necessary symlink should be there. I've got, like, I had this error I remember in, like, 2013 or something. Drove, like, 16-year-old me insane. Because I couldn't figure out what the hell was wrong with the bloody drivers. Like, this stuff still exists. Like, this is still around? What the hell? Ten years ago, it took 24 to 48 hours to get NVIDIA set up. CMake has bugs. Maybe. We're about to find out. Well, that doesn't seem like it broke anything, right? This works. Their test. Yeah. Nah. What was the... How's it erroring here? Oh, well, first of all... This is wrong. I don't like to install PyTest. PyTest is bad. Three tests and a seg fault. It says it passed. I think it just doesn't have good cleanup, right? So why is it not working when I do this otherwise, right? Because I have... Let me see, do I have... I'm gonna have lost this, right? Path is fine, isn't it? Is it running CPU or GPU? It should be doing GPU, but like... I'm doing the same build setup, so there's no way it should be failing in the Docker build. There's so much cool RL stuff to be done, man. We're so close to just having, like, the whole ecosystem fixed. You should see the Atari sweeps. They're sweet. Are you using multi-stage? Yep. Puffer Tank is a 3-stage build. If by multi-stage you mean 3 Docker files, then yes. Yeah, we just replace the entire Tesla stack with like 100 lines of PufferLib. That'd be great. Puffer just drives you everywhere. The real black pill, though, on autonomous like vehicles for delivery and stuff is that it's a regulation problem. If we just allowed like autonomous drones, we would have basically free delivery by now because there's no navigation problem. They just go up, they go to the destination, they go down. Way to build artifacts in a container and then copy what you need from that container to the one you're building. I'm using 3 Docker files to do that, sir. Yeah, I just have 3 Docker files. That counts as a multi-stage build. Okay, so here's what happens. It gets there, and then it does GPU drive build test my tests, and it fails here. So it says linking my tests, and then it fails. Dum-dums putting traffic cones on Waymos. Yeah, you know what they need to do in the Waymos? They need to they need to install one of those big like white gloved cartoon hands, on like a boxing stick or whatever, so that the car can just like whack, slap those people. That'd be funny. Um, you're building test code. I don't know why I'm building test code. Did I do anything weird? No, I don't. So it gets to the CMake, right? This is CMake-J, or what is it, make-J? They've got the release flag. How is it possible that this is different in, how is it possible that this is different when I do it here? How's that possible, right? Built target. Dash dash is it headless? Is that why? Is that because it detects it's building headless or something? I don't see anything else that would be different. If you build it manually, test is always built. Is there not a flag or something? CMake. Well, what do I do with it? Like, there's something wonky here, isn't there? So the thing it says is that the CUDA, libCUDA is not opened. But the weird thing is this build isn't even... Is there anything in this build that would cause you to need to refresh? Is there a way I can, like, refresh, like, the terminal or whatever? Like, what's the equivalent of refreshing the terminal? Because I do install a bunch of packages and stuff. Maybe it just needs, like, a terminal refresh. You can treat it as a new terminal spawn for each run. Okay. Should already be doing this. Git clone dash dash recursive. Make dir pcd build. Make dash j. Fails. Because it can't find a CUDA library. Bruh. Can't find a CUDA library. Okay, well, we're not victims here. We have We have some agency, right? We can... see. Where's the tests? This here? Get out. Get out. We just disable their bloody tests. Right? Now it'll reclone. It'll grab the new version. It will not run the test. Boom. We'll see if it breaks somewhere else. It was not breaking on the test. Well, looks good. We're gonna just assume it works. Because I gotta go. Okay, here's what's gonna happen, folks. I've got a call. I'm gonna go chat with a colleague. I'm going to finish these builds tonight. If this does not work, I don't know. We'll debug tomorrow, but I'm hoping it works. And if so, you know, I'll get like an initial, okay, steps per second, maybe, whatever, or something like that. And then we'll pick this back up tomorrow. We'll try to finish GPU drive. And then over like the next several days, it's going to be this. It's going to be finishing the Atari sweeps. It's going to be getting better MOBA sweeps. Lots and lots of like experimental hyperparam type work. All right. So, yeah, thanks for tuning in. All the stuff that I'm working on here is immediately and always free and open source. You can get all of this stuff right here in PufferLib. This is all my work. I work on this full time. So if you'd like to support my work for free, just star the repository. It helps me out a ton. I also post all this stuff on X. I'll post that as well. This is just my research stuff. It's not like a bunch of politics or bullshit. So there you go. Thanks, everyone, and